people, so welcome to today's class. Today I will be explaining myself what is Doppler effect. Doppler effect is nothing but the apparent change in the frequency heard by an observer due to the relative motion between two moving bodies, say observer and the source, or the source. Then it's called Doppler effect. It pretty much means the same. Okay, now I'll start with an example over here. Let's say I have, what's this? Let's say I have a source. I have a source. Okay, and I have an observer here, and name him O, and this as S. So as this source is giving sound waves strong with different color, sound waves like these, and the observer is getting the sound waves. So at different instances the observer will feel that there's a change in the frequency. Now that is what we call Doppler effect. So let us assume that the source is at, say, some distance x or y, whatever. So at the initial instant, that is time equals 0, let's say the distance between them is equal to the wavelength of this wave. Then d equals lambda. Okay, our initial wavelength is lambda, but if we take the second case, there we go. Okay, just to make it simple, I made it fast, like lightning fast. Okay, so previously the source was here and now it's moved there, but it was over here at a time instant t equals 0, and the wavelength, initial wavelength, we considered it as lambda. Now it has moved through this distance at some t, some time t equals t. This is t0, t1. So obviously the distance will change. It will become, or the wavelength, it will be different in this place. We take it as a lambda dash. So now, and one more thing, just forgot to tell you that the observer is at rest and the source is moving with the velocity vs. Then after time t, the distance traveled by this source would be let's take a different color, let's say orange. D equals vs into t, of course, because displacement equal to velocity into time. So this is also, since lambda or wavelength is nothing but distance, and we are finding it in terms of lambda or wavelength, this is nothing but the change in the wavelength, or the amount of distance in terms of wavelength it has traveled to this. So we get lambda naught equals vs into t. So now this lambda dash equals lambda, that is initial wavelength, minus the amount of distance, or the wavelength reduced, or actually it's displacement between these two things in terms of wavelength. Okay, hope you understood it, because most people are confused in this, because I'm taking the distance traveled by the source in terms of wavelength. I'm taking in terms of distance itself, but I'm writing in terms of wavelength. So now we write it we'll make it into a more simpler form, and just for the case, c equals to nu lambda. That nu is frequency, c is velocity of light, and lambda is wavelength. So now we have for ourselves lambda dash equals lambda minus Vs into t. So now using this we write C by Newton dash equals C by nu minus Vst, and as we know 1 by t equals frequency. Now this thing can be written as C by nu dash equals C by nu minus Vs by nu. Now reciprocaling it on both sides, we get nu dash equals nu into C by C minus Vs. Got it? So this is the required equation that we need. No, I just simplified it, so don't get confused. I wrote it directly over here. Okay, yeah. And this is when the observer is moving, the source is moving towards the observer, and if the source is moving away from the observer, obviously we'll get plus because additional amount of distance will be added. This amount of distance will be added to the actual wavelength, so here we get actually plus. So obviously when you solve it, in the end we'll get plus or minus over here. So hope you understood it. Thanks for watching.